We're continuing our discussion of drawing Lewis structures and labeling bonds and geometry. And here we go. I copied the molecule again so we could put labels on it. You're going to be doing a lot of the labels the same for different bonds, so please don't write the same label over and over again. Use either letters or numbers here. You can use symbols, but it really makes it hard for me to grade it. Okay? Like happy faces and triangles and stars and stuff, but it makes my job harder. I'll do it. But remember, when you're labeling bonds, here's a typical bond label. They have to start with the type of bond. There's only two types. Sigma, that's this symbol here, and what's the other? Pi. To figure out which sigma bond you are using, you have to know about hybridization. Remember when we put our 4 fingers up, 3 fingers up, 2 fingers up? What were the 2 things you were counting for hybridization? Just 2 things. Don't give me a type of hybridization. Give me the 2 things you count to get the right number of fingers. Sigma bonds and lone pairs are the only things you count. If you have 4 sigma bonds, sp3. If you have 3 sigma bonds and a lone pair, also sp3. If you have 2 sigma bonds, 2 lone pairs, also sp3. There's 3 scenarios. If you have 3 sigma bonds, no lone pairs, what do you got? sp2. You also have sp2 for 2 sigma bonds and 1 lone pair. And you also have sp2 for 1 sigma bond and 2 lone pairs. Okay? And then you have sp. Generally, our sps are just 2 sigma bonds. But you could have a sigma bond and a lone pair. Carbon monoxide comes to mind. But that's not really organic. Okay? So what are your angles for sp3 always? sp3, what's the angle always in this course? 1, no. When you got 4 things, that's the least separation you're going to get. Give me the smallest bond angle, please. 109.5. Now, if you're sp2, what's your angle? 3 things, you can get them further apart, right? 120. And when you have only 2 things, that's the best you can get them apart, right? What is the number? 180. There you go. Let's do it. I'm going to label, this is just a personal preference of mine. I like getting rid of the hydrogen. Like every bond where hydrogen's bonded to something. Because hydrogen, I know, can't hybridize. Do you know how I know that? To hybridize, you need to mix the valence orbitals. What's the only orbital hydrogen has for bonding? S. Can you mix one thing? No. So a hydrogen always just brings in an S bond for making bond, S orbital, sorry, to make a bond. So I'm going to do the hydrogens. And I'm going to label the bonds with letters A, B, C, D. Baby blue. Letter A. And A is going to be over here. What kind of bond is it? Sigma or pi? There's only one of them. It's always sigma when there's just one of them. What hybrid, it's a trick question, what hybrid is hydrogen using to make a bond? It's not a hybrid at all, right? It's an S. Now look at the oxygen to the right and get your fingers out. How many sigma bonds does the oxygen have? 2. How many lone pairs does the oxygen have? 2. What's the hybridization of the oxygen? sp3. The sigma bond is formed between the s orbital on hydrogen and the sp3 on oxygen. And now the s orbital is gone. The sp3 hybrid is gone. They have now combined and overlapped, and they have a new arrangement called a sigma bond. It's a type of orbital, people. It's just, there's no more atomic orbitals. It's a bond in a molecule, do you agree? It's called an atomic orbital now, and that's its name. And there's a lot of those. Let me find 5 more at least. How do I know that's an A as well? And this, and this, and this, 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 I'm sorry, the colors match on the label and the molecule. Every atom that hydrogen's attached to there has sp3 hybridization, whether it's 4 sigma bonds, 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 or 2 sigma bonds, 2 lone pairs. Sigma, sigma, lone pair, lone pair. Oxygen's sp3. 4 sigma. Whoa, 3 sigmas, 1 lone pair. That's also sp3. And I missed 3 A's, didn't I? Oh, don't label the same bond twice. Wow. No, the H's on the right are not. I don't know what I just undid. I'm having trouble erasing that little A. My eraser's too big. There. Yeah, sadly. Why? Okay. Yeah, these are sp2s, all here, 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 and yeah, those. I'll do those next because they're H's. They're all the same because the H is attached to an sp2 atom. And you tell me you know that. B, it's a sigma bond between an S on hydrogen and an sp2 on the atom it's attached to. And there's a significance to this. And I'm going to leave it up to you to watch the morning video for the explanation, because, you know, I don't like saying the same thing over and over. Watch the morning video with the one question in mind. Why is B a stronger bond than A based solely just on the name? And it's pretty clear in the morning. You'll see it. Comes at about it's part 2, like this will be part 2, about the 3-minute mark. It's a guess. It's not, you don't need it for points on this question. But C, I'm just going to go and finish every bond now. And it starts left to right? Sure, why not? C. What's the hybridization? Oh, sorry, what's the type of bond first? Is it a sigma or a pi? It's a sigma. Learn how to draw a sigma, please. It's a circle with an eyelash. That's how I like to describe it. I don't know. Does that work for you? Eyelash to the right from the top. And what's the hybridization of the oxygen? It's got 2 sigma bonds, 2 lone pairs, sp3. What's the hybridization of the carbon to the right of that? The carbon to the right. 3 sigmas, no lone pairs, sp2. There you go. And there's going to be a bunch of those, I'm pretty sure. Anytime there's an sp3 hybridized atom, covalently bonded with a sigma bond to an sp2, that label fits, whether it's left to right or right to left. You might see the sp2 first and the sp3 second. That doesn't matter. Let's see. That's sp. These are both sp. That's sp2 and sp3. Bingo. They're in the wrong order, but that doesn't matter. That's a C, and so is this. sp3 on top, sp2 below. And C. sp3 to the left and sp2 to the right. These are both, that's sp, so no good. sp2, sp2, no good. sp3, sp3, no good. sp3, sp3, no good. No good, no good, no good. I think I got them all. Go back to my original molecule. D. We already did the hybridization of the carbon underneath. What was it? The red carbon below the letter D. Hybridization, please. sp2. 3 sigmas. 3 sigmas, no lone pairs. What about the oxygen above? 1 sigma. Only one of these is a sigma bond. I hope you know that. 1 sigma, 2 lone pairs. That's 3 fingers. What do you got? sp2 again. And I think we got at least 2 more of those. Here, D, and here, D. What's the second bond between the carbon and oxygen called? Pi bond. I'm not going to do pi bond now. I'm going to do it later. You'll know why if you watch the morning video. But I'll say it again because I like saying it. I do pi at the end for dessert. Pi for dessert. You and me. Okay. Rhubarb. That's my favorite. And the only one I think. And D. Save the pi's till the end. What about E? What's the hybridization of the carbon to the left in the E label? We've done it twice already. Same carbon. sp2. And the carbon to the right, where there's a sigma that's black and a sigma that's red, and that's it. sp. Yeah, that's stronger than the one above it, for reasons that will be mentioned in the morning video. sp2 to sp. Any more sp2 to sps? No, that's an sp to an sp3. There's an sp to an sp2. Bingo. E. And an sp2 to an sp2. We missed an sp2 to an sp2, people. No, that's an sp to an sp2. Sorry, we didn't miss anything. It's E. We didn't miss a thing. And that's it for those. And F. F. What you got? It's the first bond, so it's a sigma. Carbon to the left has a red and a black sigma, and that's it. No lone pairs. That's sp. Carbon to the right has 2 black sigmas. That's it. Also sp. That's our strongest sigma bond here. Got the highest percentage S. That's a clue. And G. Sigma between sp to the left and sp3 to the right. Yeah. I think that's unique. There's no other ones like that. But there's a lot of H's, I'm pretty sure. Both atoms have 4 sigmas. sp3, sp3. Same for this. Same for this. Same for this. Same for this. We got a lot of H's there. And looking for missing bonds. Are all the sigmas done? I think we missed this one. I. No, that's a D, isn't it? The one I labeled I is really a D. sp2 to sp2 is a D. It's, hey, I is for dessert, and it doesn't go there. All right, let's do dessert in pink. One of those pi bonds is I. The other can't be I. Can't be the same, right? You're a new bond. You have to have a new name. All right, you want to see a pi bond, what it looks like? We don't use hybrids to make pi bonds. We use p orbitals. Remember what p orbitals look like visually? Do they look a little like this? They got 2 lobes. That's a p orbital. And this is a py orbital. Here's a different one. That's pz. Here's a different one. That's px. None of them take up any of the same spaces, do they? Just these parts of the orbital, the colored parts. So when you want to make a pi bond, you have to overlap a p orbital with another p, and they only overlap if they have the same orientation. There's a bond between 2 p orbitals, sorry. p orbital that's called py, and py. Make a pi. This is what a pi looks like. This is a new orbital. It's called a pi bond. See the overlap? So the electrons spend their time in the overlap region. So you can call your orbital pi py py, or pi pz pz if it's this one, or pi px px if it's that one. But you can't have an orbital pi py pz. They don't overlap. You can't have a py px. They don't overlap. They got to touch. So you got to show me you know all that stuff. So I'm going to say is pi. And you got to tell me you know p orbitals overlap to make pi bond. And then the last piece of information, there's a lot of information in this little label. You got to pick two matching letters down there underneath the y, the p, sorry. Y is a good one. They must match, or else it's not a bond. And you remember filling atomic orbitals, right? Once you filled an orbital, you had to move on to the next orbital. That's why we filled S first, because it was closer to the nucleus. You remember all this stuff a little bit? Yeah. And then you moved on. Once the S is filled, you got to go to the P. That's a little further. Same here. And once you've filled a P orbital, like you have with this filled P and a filled P overlapping, this is now a pi, you can't use that or any of those orbitals anymore. So the next bond can't use the same orbitals, but it's the same kind of bond, right? So give me a suggestion for J. The second pi bond can't have the same name as the first. So just give me another name that's acceptable. What kind of bond is it? Pi. Can't say sigma. You already made a sigma. It was called the letter F. The other two must both be pi, right? Matching P's that aren't Y, because you've used Y. PZ, PZ? Pizza, pizza? There you go. Oh, now that's an sp3 on nitrogen and an sp3 on carbon. She's correct. I missed a bond. She's talking about this one. So which label says sp3, sp3? Is the letter H, and we better put an H there. Thanks for noticing that. Now, if you had what I had on a test and you missed one label, I'd probably let it slide. But once you get to 2 or 3 missed labels, I'm going to start talking. If everything else is cool, maybe a quarter point, you know. I realize we're all in a hurry here. And things like missing a label are going to happen. And you shouldn't be held against it. I mean, but if it's multiple, I got to do something. It's a question with a big blank. Yeah, and you're free to feel free. There's extra pages at the end. You say, I can't get this here. I write big. Dr. Whitaker, see page 12, right on the question there. Please give me some kind of notice. They come up to me after they get their test back and say, look, I had it on page 12. So come on, tell me that, please. That can just make my life easier. Okay, so that's a lot of points. I think that's 7 or 8 points. That section, that's a lot of work. And you notice, instead of writing labels, the same labels over and over, which would take forever, this saves a lot of time. And that's B. And we'll do C and D, D and E. Is that B? Label each bond. There's no part C. That's why I'm confused. What? Yeah. D and E, we'll do in the last video. All right. So coming up.